record. We are live recording. So we have a survey of athletes at a high school is conducted. Let's steal that text into my worksheet. And figure this out. Hopefully that is readable. All right, so let's see. Survey of athletes at a high school is conducted and the following facts are discovered. 92% of all athletes are football players, 6% are basketball players, and 3% of the athletes play both football and basketball. If an athlete is chosen at random from the high school, what is the probability that they are either a football player or a basketball player? Okay, cool. So this is a classic problem where we have to be careful about double counting. And so I'm going to kind of sketch out a situation for this. So let's suppose we take all of the athletes and stick them in the gym. And so here's my picture of the gym. And at this school, they only have football players and basketball players. That's it. So then we want to cheer on all the athletes. So we have them get onto the court so the rest of us can clap for them. And we have them grouped together by team. Now, there's going to be a slight problem there, because we say, hey, all the football players, you go over here, and all the basketball players, you go over here, and there's going to be a little bit of overlap between them. So those people that play basketball and football are going to have to stand in the middle so they can kind of be with the football team and kind of be with the basketball team. All right, so let's see what we got. 92% of all athletes are football players, 6% are basketball players, and 3% of the athletes play both basketball and football. So that 3% has to live here in that overlap, and I didn't draw a very good picture of that. Let's make that, well, yeah, I'm gonna make it a little bigger just so I can write in it. All right, so there's the basketball ones. So that 3% goes right here. Now, I've accounted, right, so the people go down, let's just say the basketball and football players, they go down first, the ones that play both. So they're going to kind of stand in the middle, and then the other football players are going to come down, the basketball players are going to come down. We've already accounted for 3% of that 92%, so that's going to leave, what, 89% left. So in the football circle, I have 89 plus 3, which is 92%. And then for the basketball players, 3% of that 3% is already there. The other 3% is going to then walk down and stand on the court. And so there's the total of 6% for the basketball players. And so just all together, right, what do we have? Well, we have 89 plus 3, which is 92, plus another 3, which is 95. So what does that represent? So the probability that somebody is a football player or a basketball player, there's a 95% chance if we randomly select somebody that that's going to be the case. And that's what this question asks about. And I mentioned this Monday, and there's a recording on this also, that the word or in mathematics is different than the word or in real life. There's an inclusive or in our language, and there's an exclusive or in our language. So if I go home and say, hey, I want some dessert, and my wife says, okay, you can have ice cream or you can have cake. The implication to me is that if I pick cake, I can't have ice cream, right? In mathematics, or so that's an exclusive or, right? We exclude the other if you choose one. In mathematics, it's an inclusive or, meaning you get one, the other, or both. So in mathematics, when we talk about a group that is football players or basketball players, that means show me all the football players, show me all the basketball players, but that includes people that play football or basketball. And that's that group right there. And we have to be careful about double counting if there's an intersection. So the probability that I choose somebody that plays football and basketball, that's that 3%. And that's what we call the intersection of those two groups. Okay. So I hope that was helpful. All right, so next, problem number 17. And I guess I should put an answer in there since I went all this way to do that. Should be 95%. Hooray. And again, I helped you through that problem if you just did that along with me right now. So this is one of those situations where you're going to want to do another and make sure you got the idea down. And each time you get a slightly different set of numbers to go with it. And that's super important. So anytime you get help on one of these problems or it was a struggle for you, be sure to do another similar question. 17 is the next question. Sweet. So it's important that you've done the previous problems, and there were a couple here, and let's see, I kind of walk you through it. So in here, I do all of the calculations for you, and then I just ask you, based on the table, can you answer some questions for me, and I color code some stuff for you. So this is like the easy version of this false positive, false negative test idea. This one's a little harder in that you have to fill out the table and then answer the questions. So it's very similar to the last one. I start the table for you, you have to finish it and calculate the answers. And then the third version of this is I just give you the basic information and you got to figure out how to make the table and answer the question. All right, let's do it. And let's see, I want to be consistent with the other ones. We have tests on, oh, I wasn't consistent there. So notice the first table I do positive, negative, and then virus on the side. And the second table I did positive, negative on the side, and the, oh wait, is it the same? Oh yeah, I do the table kind of backwards. It doesn't matter whether you do rows or columns for this. You can go either way. All right, so let's copy it in there. Page. So I'm going to go back and forth between writing on paper and writing on my spreadsheet here. Button. Paste. Okay, so a certain disease has an incidence rate of 0.5%, 0.5%, less than 1%. So what that means is in a given population, like maybe the United States, any resident here, less than 1% of people end up with this disease. If the false negative rate is 7% and the false positive rate is 1%, compute the probability that a person who tests positive actually has the disease. Okay, so let's brainstorm what some of this stuff means. So we have an incidence rate. And sorry about any background noise. It's extremely windy on campus here. And then there's some other weird stuff going on like helicopters. Incidence rate is 0.5%. And the incidence rate is the percent of the population that has it. So percent of population with the disease. Be careful with that. It's a percentage, so to use it later, I'm gonna probably want it as a decimal. Percent symbol means divide by 100. So that number is really 0.5 divided by 100, which is 0.005, right? So that's the tenths, hundredths, thousandths. So 0.5% is 5/1000ths as a regular number. And a common mistake here is to mess up that percent conversion when you're doing calculations. So if you're using a calculator, then it's super important that you enter it as a decimal, unless your calculator has a percent button that you know how to use. All right, false negative. What the heck is a false negative? So it has a 7% rate. And so what does a false negative mean? Well, it means the test came back negative. So we have a negative test. Negative test. And a negative test means the test says, hey, no disease, you're free, you're clear. Oops, disease. But it was wrong. You really have it. In probability notation, that would be the probability of having a negative test when we know, that's what that vertical bar means, I know that you have the illness, so that you have the disease. Yet another way to think about this would be to say, what is the percent of people who have the disease come on, pen, disease that test negative. Right? These tests aren't perfect, so some of the times they are wrong. So if we looked at all of the people who had this disease and we looked at what portion of those, what number of those have the disease, then that's this number. So as far as like a fraction goes for false negatives, then this would be equal to the denominator is people who have the disease, total with disease, and the numerator would be people who have the disease and test negative. So disease and negative test. And we'll look at that in a table. But these are the few different ways I kind of think about it when I'm trying to figure out what I'm talking about. Then we got the false positives. And really, you can't answer this kind of question unless you know what these things mean in kind of English and math speak. So where do we go? False positive rates. Positive equals 1%. And the false positive means that you came back with a positive test, but you don't have it, right? It said it was positive, but false, it's wrong. And so kind of in the probability speak, in this conditional probability notation there, that would be the probability of a positive test, knowing that you have no disease. Right? It's wrong, it's false. The test is incorrect. And so similarly, if I write that as a fraction, that would be in the numerator, no disease and positive test, if we look at a table, divided by, let's move these tools out of the way, divided by all the people that have no disease, or total with no disease, total of no disease. Okay, so those are the definitions, how we interpret that. So now we just got to put that together into a table. So I'm going to whip out my spreadsheet next. Just take a quick note here. Negative is 7 and false positive is 1. Spreadsheet time. This is number 17. All right, so in my table, let's see, how do I want to organize this one? I'm going to put the test up at the top. So this is positive test, negative test. Over here, you have the disease, dis-ease, no disease. In order to do this, we have to do subtotals. So I'm just going to put a total row here and a total column here. And then these are like the main calculations there. We'll make those yellow. And then over here is going to be the total population I choose to work with. Let's make that greenish. And in different videos, you'll see different approaches on this. Usually we pick the population to be a big number like 10,000 or 100,000 or 1 million. And it's up to you what you want to choose that to be. I think I'm going to do 1 million people today. Then I'm also going to put commas on these numbers so they're easier to read. And I don't think I'll need decimal places with 1 million. So you might like say, well, why did you do 1 million and the other guy did 10,000? Or you did 10,000 in another video. If you don't pick a big enough number here, then you get decimal amounts of people in here, which kind of looks and feels weird. You could put the number 1 here if you wanted to, then you'll have a lot of decimals to work with. So this right here is my population. Okay, so let's try and figure out what we can do. The question again said a certain disease has a 5% incidence rate, false positive rate is 7%. So I can only use, for example, the false positive rate if I know the total number of disease. And I don't have no disease, and I don't have that yet. I can only use the false negative rate if I know the total number of people who have the disease, but I don't know that yet either. All I have is the population. Can I use the incidence rate? The incidence rate is just the percent of the population with the disease. So if I have a population, I can calculate the number of people with the disease. So that's where I have to start. So show the desktop back here. So I can calculate the incidence rate. So I'm just going to make a note over here. Incidence rates. And I can just type it 0.5 with the percent symbol, and the spreadsheet will interpret that correctly. It gives me an extra decimal, no big whoop. And so I don't have to worry about converting it to a decimal. It'll do that for me, which is kind of sweet. So I'm going to do that. So this is the percent of the population that has the disease. That's what incidence rate means. So that must be the total for the disease row. So to calculate that, I just go equals, take that 0.5% and multiply it by the total population, because that's how we use percents usually. We multiply by something. So that says 5,000 people would have the disease, okay? If there's 1 million people in the population at a 5% incidence rate. Okay? So I'm going to color code those things so they match. And they can be pink today. All right. So once I know the total people who have the disease and I know the total population, I can just subtract to figure out who doesn't have the disease. So that one's pretty straightforward. Just equals, take your population, subtract the people who have the disease. And so now I know how many people do not have the disease. So then I can go back and try and do the false positive and false negatives because I have more information now. All right, so let's see if we can apply that. Back to my notes. What does a false negative mean? So false negative over here is the percent of people who have the disease that test negative. So if I know how many people have the disease, then I can use this percentage to calculate how many test negative. Okay? And that's why I was writing all this stuff out, because I'm trying to brainstorm. What the hell does what the hell does a false negative mean? And I had to write quite a bit to wrap my brain around that. And since you're new to this, that means it's going to be slightly harder for you to wrap your brain around. Practice, practice, practice. Okay, so this is definitely one you want to try a couple of times to make sure you can get it right. And then the application is basically this problem, but with different numbers in a different scenario, where we actually describe what is the disease and what test are we applying. So false negative means it's the percent of people who have the disease, but the test incorrectly says they don't. Okay, so this should be the false negatives right here. They have the disease, the test should have said positive, but it did not. So that's a false negative reading. And my false negatives are 7%. So I should just be able to take 7% and then multiply that by the 5,000. And it should be 350. Now, I like to document everything I do in the spreadsheet. So over here, I'm going to redo that. I'm going to put false negative here. I'm going to enter the 7% there. And I'm going to redo this calculation by saying, hey, grab that percentage and multiply by the number of people who have the disease. And I get that same 350. Right? Could you have calculated that in the calculator and typed it in? Sure, but a spreadsheet is a calculator. And if you look back and say, oh shit, it wasn't 7%, it was 3%, right? You can retype the 3, and if you did it correctly, it'll recalculate that number there. Let's fix that, and let's color code that. Do you have to color code it? No, you don't. Let's make you guys purple. And purple. Oh, that's too close to that color there. Light blue maybe. Sure. All right, then false positive. So false positive, that was 1%. Oh, by the way, since I have the total and the negative tests, I can do a subtraction to figure out how many people tested positive, right? Because this is the total for that row. I have one number, subtract to get the other. So I could fill in that right away, and then I'll do the false positives. So that would be equal the total minus that. Okay, so if 350 people tested negative and there were 5,000 people that had the disease, then that means 4,650 must have tested positive that had the disease. All right, false positive rate is 1%. Let's look back at what a false positive is. A false positive is a positive test, but you don't actually have the disease. So the positive means you went to the doctor and the doctor gives you the test and says, yep, you got strep throat. But later we do some more rigorous testing and find out, oh, you didn't. The test was mistaken. Okay? So if we took a group of people and we knew some of them had the disease and some of them did not, and we gave all of them the test, we could figure out the false positive and false negative rate. Now that's a sample. Every sample is going to be a little different. So manufacturers of these tests are supposed to do trial after trial after trial with these, with a bunch of people each time to try and estimate what these rates are. Because you don't know, right? This is all mysterious stuff. You have to do testing of the test to see how it works. And we have yet to make many tests that are always correct, just not within our realm of ability. All right, so let's see. If we think about it like with the percent of people, and we kind of like modify this sentence up here, but for this one, it would be the percent of people who don't have the disease that test positive. So if we know how many people don't have the disease, we can figure out how many tested positive. All right, so I'm gonna just kind of type that into my spreadsheet to help me answer this last part. So the false positive here would be the percent of people who don't, so do not have disease that test positive, meaning the test says they haven't. So that would be a false positive. So if we know the number of people that don't have the disease, we can figure out how many of them have a positive test. And we happen to have that because here is my total row. That subtraction gave me, if there's 1 million people, 995,000 don't have the disease. 1% of them will actually test positive when they shouldn't. So I can just say equals that false positive rate times the total number of people without the disease. Okay. So I have to be able to process what the heck the phrase false positive means and false negative means in order to make these calculations. And let's color code these guys. Oh, I'm running out of colors. Orange, will that stand out? Sorta, kinda. Looks too much like that color there. Let's pick a different color. I'm gonna go with green, even though I'm already using that. Okay, and then a simple subtraction will give me this number. So this is the total for that row. I have part of the row I can subtract to find the other part. So basically the way this works is pick a population, multiply to get the incidence rate, subtract to get the rest of the population, multiply to get the negative test rate, subtract to get the other number, multiply to get this number, subtract to get that number. And we can, so it's just this series of multiply, subtract, multiply, subtract. So this would be the total number without the disease minus the ones that accidentally tested positive. And so this gives me the true negatives. Okay? So most people have a true negative test. And over here, of the 5,000, most of them have a true positive. And then I do want to do these subtotals down here, partly to check if I did this stuff correct. And I'll show you why here. So here, I'm just going to add up the two numbers above. Same thing over here, add up the two numbers above. And then these two better add up to 100 or a million, otherwise I screwed something up. Good morning, Olivia. It's so nice of you to join us. So I'm just going to double check that these two add up to the right amount. Does that mean I did everything right above? No, but it's a step in the right direction. Okay, I still accounted for my million people. Okay, so we got the table filled out. So now I can answer those two questions. So let's look back at what the question was. Compute the probability that a person who tests positive actually has the disease. All right, so we got to brainstorm what that means and how to use the table to answer it. Olivia, we are doing question number 17, and this is being recorded. And that will appear a little later this morning in my YouTube playlist at the bottom. All right, so new page. What the heck are they asking here? And again, these are complicated problems. I can't just read it and know the answer. I got to think hard about what the heck's being asked, and I got to kind of go back and forth between the given information trying to figure it out. So to compute the probability that a person who tests positive actually has the disease. Okay. So the probability I'm trying to find, so I'm going to use some notation, then I'm going to think about it in plain English too, like I would try and explain this to my mom. I want to find the probability a person tests positive, I think, knowing they have the disease. All right, did I interpret that correctly? I'm going to think about that some more. Alternative is switching these two. So compute the probability that a person who tests positive actually has the disease. So I think, like in plain English, I might say another way, what is the percent of people who have the disease that test positive? Okay, so I got to think about it. Am I really interpreting that? That is not. I spell positive. Let's try it again. Positive. What is the percent of people who have the disease that test positive? Compute the probability that a person who tests positive. Compute the probability that a person who tests positive actually has the disease. I am 99% sure I am interpreting that correctly. All right, so to figure that out, what this says, so anytime you have a conditional probability, this knowledge that you're introducing in there gives you your new denominator. Meaning that's all you care about. Okay? So in my table, where I have positive tests and negative tests, and I have people that have the disease and people that don't have the disease, what I believe I'm being asked for is to only focus, let's use a highlighter, on the people that actually have the disease, and then look at those that have a positive test. So of the people that have the disease, what's the chance they test positive? So that is a true positive rate we're trying to calculate here. So then we look at our table and figure out what that is. True positive. All right, back to the spreadsheet. And let's see, I already copied that. Spreadsheet. So I'm just going to put a note. How did I accidentally make that colored? Weird. So I'm going to paste in my question I'm trying to answer, and my interpretation underneath with math notation is the probability that someone has a positive test. Vertical bar means knowing that they actually have the disease. That's what I'm trying to compute here. So again, that knowledge there in the conditional probability changes your denominator. So I only care about this row here. And in that row, I just want the people that tested positive. So equals the percent who tested, the number who tested positive out of, divide by the total who have the disease, right? Because they actually have the disease. And that should be 93%. And I want a high false, a true positive rate, because that's what I'm kind of looking for. Do you have this disease? So we know how to treat it. Another question is, what's worse? Knowing testing positive and you don't have the disease, so we say, hey, it looks like you got it, but you don't, and we treat you. Or the other way, you test negative, but you actually have the disease, so we say, hey, you don't have it, we're not going to treat you. So that's why doctors are usually pretty cautious about these tests and maybe say, well, you didn't test for strep though, but we might give you antibiotics anyway, because we don't want you to end up with something worse like scarlet fever. Or cancer, right? We got to follow up vigorously with cancer, because if we accidentally, go with a false negative, then we're not treating a disease that somebody has. So, and let's see, it doesn't have a percent symbol out here, so that means I need to enter this as a decimal, accurate to at least 3 places. And according to my spreadsheet, that came out rather nice. 5,000 is a nice denominator. And if we expand that, you'll see there are no other decimals. So it's 0.93 should be the answer here. All right, fingers crossed. Did I do the right interpretation? I get the wrong interpretation, or I have a wrong calculation somewhere. All right, cool. I got something wrong. So this just emphasizes these are hard problems. All right, so either my mistake is a mistake in the table, or I have the wrong interpretation of this right here. So let's rethink that. And does it say anything about a percent? That's the other thing. I have a problem reading the fine print some days. It says enter a mathematical expression, which could be a decimal or a fraction. Doesn't say anything about a percent here. Yeah, so it must be a decimal. Okay, does my table have the right percentages? 0.5%, 7%, 1%, false negative, false positive, false negative, false positive. Got that right. Okay, so all I can conclude here is that I interpreted that incorrectly. So let's start over on that one. So something, I don't know if I've pointed this out before, most of the mathematics I've done in my life has been wrong, because a lot of math is very hard and I haven't done it before. And even when you've done something before, it doesn't change the fact that it's hard. Okay, so compute the probability that a person who tests positive actually has the disease. I thought I had the right interpretation about that, but I suppose not. Compute the probability that a person who tests positive actually has the disease. So rephrasing that. I guess my interpretation of that is backwards. So then, positive tests must be my current group. Right, my knowledge. And then I'm looking for the probability that they have the disease. So what if I rephrase that? Compute the probability that a person has the disease knowing, let's write that down. Compute probability that a person has the disease knowing they test positive, which is not a true positive rate, but just a different question. Compute the probability that a person who tests positive actually has the disease. Compute the probability that a person has the disease knowing they test positive. All right, I guess that is the correct interpretation. So that would be the probability that they have the disease knowing they have a positive test. All All right, off to the spreadsheet. At least 3 decimal places. I don't think that's the issue because my third decimal place was a 0 and the computer is going to treat that the same. Did yours work out okay, Andrew? You haven't tried it? Okay. Yeah, I'm thinking my first interpretation was the incorrect one. So I'm going to go back to my spreadsheet and make that actually this right here. Seems to be incorrect. Probability that a person has the disease knowing they have a positive test. Okay, so in this case, I would want to focus on the positive tests and then look at the people who have the disease. So that would be equal to the number of people who have the disease and tested positive divided by the total number of people who tested positive. And that one would give me 31.8% or 0.318. All right. The other alternative here, and that is the correct interpretation. Okay, so my first interpretation was incorrect. I must not have had enough coffee today. So, compute the probability that a person who tests positive actually has the disease could be reinterpreted as compute the probability that a person has the disease knowing they tested positive. So in other words, this would be the percent of people who test positive Okay, yeah, that's Andrew, Melinda, that sounds in the ballpark of what I had there. And you're using, I assume, the second interpretation. So these are a couple of ways to interpret that question there. Oof, that was challenging. Anyone else joined us? Don't think so, not since Olivia. Okay. All right. Are there other questions? Why is that flashing? I don't know. Interesting. So this is about the hardest problem in the homework. The next one's pretty challenging too. If you haven't tried it yet, you should wait before you ask. No other questions at the moment? Nothing in the chat. So side note, until someone asks another question, you're going to work on the practice now, Andrew. Okay, good luck on that. If you haven't checked out your take-home exam, I graded all the take-home exams, except for a couple who I couldn't read their spreadsheet, and I'm waiting to hear back from. If you want to, if you haven't already viewed my feedback, then when you go to the exam page, you would select view scored assessment, or there's another link over here, and then at the very bottom, we'll show you my feedback. And if you have any further questions, be sure to get back in touch with me about something that went well or didn't went well. And then today I'm working on application 4 and some critical thinking assignments. And I've gotten several requests for, I have some optional practice problems. Anytime something says optional, it's not part of your grade. Another set down here. And I put those in there, I mentioned earlier, because probability is hard. Some people take, multiple courses on it. We're just doing a week on it. So I put some extra practice problems if anyone's struggling with it, which I expect most people to struggle with this. And the requests were, could that be worth extra points? And my usual reaction to that is no, but I'm thinking about it. So maybe. All right, so if you don't have any further questions, feel free to sign off. I'm glad you could join me for a little bit. If you have a question, please ask. I've recorded parts of these sessions the last few days, and they're appearing in my end of my YouTube playlist. And if you haven't checked out those notes, step-by-step guide to working with contingency tables, that covers the problem I just went over with a different set of numbers. Okay, sounds good. Okay, unless you have any questions, I am going to sign off also. Okay, well, have a good day. I will see you in the near future. Bye-bye.